Welcome back. Today in class in Math 65, we were looking at 2.2, and this is where we introduce the derivative function. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. And there was a couple examples we didn't finish. One was find f prime of x if f of x equals the square root of x. And I wanted to walk you through this one. We're going to set it up. We've got the limit as h goes to 0. We're going to plug in x plus h into the square root. So I got x plus h. And then I've got minus f of x, which is just square root of x all over h. This one's not too messy, so I'm not going to do the 1 over h in front of it. If you remember what we did in previous sections with radicals, a common go-to is multiply by the conjugate. And if we do it on top, we got to do it on bottom. This took advantage of a minus b times a plus b is a squared minus b squared. And so this limit goes to, as the limit as h goes to 0, this cleans up some. We've got x plus h squared, square root of x plus h squared, minus square root of x squared. And on the bottom, I'm not going to distribute. I'm just going to leave this alone because we saw that a lot of times that h cancels. So we work that out. We've got x plus h minus x over h times square root of x plus h plus square root of x. And you'll see that I'll show all the steps. The x minus x goes away. We have h on type, then h on bottom multiplied by square root of x plus h times or plus square root of x. The h's go away. And we have a limit as h goes to 0 of 1. Don't forget, when you cancel stuff on top and bottom and there's nothing left, you should have a 1. Square root of x plus h on bottom plus square root of x. Now, when we evaluate this at 0, I have 1 over square root of x plus square root of x. And this is 1 over 2 square root of x. Okay? So that's f of x. If we wanted to find the slope of the tangent line, for f of x equals square root of x at x equals 9. We already have the formula. This was f prime of x. We'll do f prime of 9 equals 1 over 2 square root of 9, which is 1/6. That was one example. This was example 3 in the lecture notes. And then example 4. If I can lift this page up. Example 4 is show that f of x equals the absolute value of x. Is not differentiable at x equals 0. So f of x equals absolute value of x. Or actually, we can do it as a piecewise function. If x is greater than or equal to 0, this equals the square root of x squared. I didn't give myself a lot of rhymes, so I'm gonna like put a little line here. And then if x is less than 0, it equals negative x. Square root of x squared is positive x, but I think it's worth showing the square root of x squared. So let's look at our limit thing. Let's see what this is doing. If we want to show its derivative let's just find its derivative in general. F prime of x is the absolute value of x plus h minus x all over h. That's the general form. This can be a pain in the ass for looking at different values. So let's look at 0. F prime of 0 is the absolute value of h minus absolute value of 0 over h. So f prime of 0 equals absolute value of h over h. Well, these have different, h has different values. Absolute value of h has different values. I'm missing something here. I don't have limit as h goes to 0. Oh my God. This is like instant markdown on points. You do this shit on a test? No. Trouble. I'm not even gonna write, I'm gonna rewrite that shit right there. I gotta do it right. F prime of 0 equals the limit as h goes to 0 of absolute value of h over h. Now this is different for x is greater than 0 and x is less than 0. So let's look at the limit as h goes to 0 positive. And the limit as h goes to 0, I said positive, I meant negative. I'll put positive there since I said it first. And then we'll do h goes to 0 negative. This function is now for positive values of h. It's just h. So h over h, it equals 1. And when we look at the absolute value and we're approaching it from the negative side, it equals negative h. So the absolute value of h turns into negative h for this one over h. And that cancels out to be negative 1. So we can see the limit as h goes to 0 from the negative side of f prime of 0, which is negative 1, does not equal the limit as h goes to 0 positive of f prime of 0, which is positive 1. So the limit doesn't exist, which means f of x is not differentiable at x equals 0. The limit doesn't exist at x equals 0. That's important. It does exist everywhere else. And that wraps that up, and we'll call that a wrap. Peace.